Okay, let's see here. It says particle of charge. So this is question 102 from chapter 11. It's kind of at the end of the chapter where it's the additional questions, or I think this might even be challenge questions. It's from the portion of the text chapter and the questions where it doesn't tell you what section it's from, and I think that's why in the hint I didn't actually put in the section reference. But I think mainly you use magnetic force. So a particle of some charge and mass move. Let me start sketching it, and I think it might be good for me to just sketch the right-handed coordinate axis first. So in the perspective view, this is one way to sketch the right-handed coordinate axis, x-axis, and x cross y. Let's say I draw y to the right. Then x cross y gives me z upward. So this is the right-handed coordinate axis. This is one of those circumstances. I know there were some electrostatics videos where I accidentally used the left-handed coordinate axis. Didn't change anything. Now that we are dealing with the magnetism, it matters that you use the correct coordinate axis. Okay, so we have some particle. Let me get it's crossing. Oh, okay. So I want to mark those points. It's crossing y equals r here, and it's moving in the minus x direction. So the particle is kind of moving in this direction with the V naught. Cross y, yeah, and I think it's moving in the xy plane with the velocity, initial velocity being in the xy plane with the minus x direction. I think it's not going to move in the z direction at a particular time. There's a negative charge, okay, minus q fixed at the origin, and there exists a uniform magnetic field. It is found that the particle moves in a circle of radius r about the minus q. Find the direction and magnitude of b naught. Okay, so it's a positive charge. So I guess so let me just draw a free body diagram of the charge. So the free body diagram of the charge, I'm gonna imagine I'm looking at the charge from the plus x direction, like from over here. Then there's a the force in the direction of minus y axis, or leftward, the way I'm drawing. That's the electrostatic force. And I think let me just assume that the magnetic force, however it's set up, it's going to set up in a way to give me the magnetic force in the same direction. If somehow my guess turns out to be wrong, then when I finish calculating the value of the magnetic field, I'll probably get a minus sign. Then I can just flip everything. So with this, really the relationship I'm looking for is that when I calculate the net force, the sum of all the forces, that should give me the centripetal force, which will be mass times v squared over r. And I think the way it's set up here, both the electric force and magnetic force, almost by its property, shouldn't be changing the tangential velocity of the particle. So I do have the velocity of the particle, just v naught. And so let me just write this out. The electric force, the magnitude of it is going to be the Coulomb constant times, or let me actually make sure I don't skip steps. So this is going to be the magnitude of the electric force plus the magnitude of the magnetic force equals mv squared over r. And what am I looking for? I'm looking for value of the magnetic field, so I need to expand out the left hand side a little bit more. I need the electric force from Coulomb's law is Coulomb constant times for the magnitude, it'll be just the product of charges, the magnitude of charges, small q times the big Q. I already handled the direction, divided by the r, distance squared. That's the electric force. And the magnetic force, I guess I should figure out in what direction the magnetic field should be. So I'm trying to do V cross B, so that's so V cross B should be leftward, so B should be downward. So V is into the screen, yeah. So let me sketch it and make sure it makes sense from my perspective. So if my magnetic field in this region is downward, then let me do it from my perspective. V cross B, yeah, that'll give me a magnetic force that's leftward in this direction. So for the magnitude of magnetic force, it's the amount of charge, Q, times the speed, V naught, and V cross B, because here I'm setting magnetic field to be perpendicular to the charge, and I think those are my options. The magnetic fields will be along one of the axes. V cross B, leftward. So V B, that should be equal to mv squared over r. So oh, but they are not letting me set the magnetic field to go in the negative direction. They are forcing me to set magnetic force field to be along the positive direction. So I think I have to say it's along the positive z-axis, and I do have to introduce this minus sign in order to actually get, you know, the magnetic force that will be pointed this way. So let me make that correction. So let me do that in different color. So the correction would be so not this, but it has to be along the positive direction, because of restricted choice. And that means with the V cross B, my magnetic force will actually be rightward, but my net force should still point in the leftward direction in order to get centripetal acceleration. If net force is to the right, then you don't get circular motion. So so all this is fine, but here this should now be minus sign to match with the different direction of magnetic force. Okay, I think I'm ready to solve for magnetic field. So let me just get that expression here. So I'm just gonna do the most of the algebra in my head, but what I'm doing is I'm gonna move this over to the right hand side, move this over to left, divide through by Q V naught. That'll leave me with a B on the right hand side, which I'll write first. So B is equal to the kind of what I get after moving turns around, K E Q Q over R squared minus mv squared over R. And then there's a product I have. I'm dividing everything by Q V naught, so 1 over Q V naught. So that should be my expression for magnetic field. I think those are all the symbols I have. So let's see. 1 over, and I can use the vars menu to make sure I have the correct symbols that the question will recognize. That times Coulomb constant. Oh, I forgot to allow the use of permittivity of free space. I might say something in the question about using above it. I think it's fine. Yeah, use Coulomb constant, permittivity of free space. People should know how to use both. Divided by R squared. You could type it from here, and then I have minus. I have mass, right? And then V. I forgot to say V naught. It should have been here. V naught squared. Divided by R. So that I think should be correct. Let's hope and check. Good. Yeah. So that's the setup question. I guess I didn't need all from alpha. You kind of have to. I like always sketching the setup, and especially for a question like this, yeah, you kind of have to sketch it because it's hard to kind of imagine the whole spatial arrangement just in your head, or through memorize the formulas. But once you kind of sketch how things are arranged in a real space, then you'll get a better sense of what your answer should be.